Hello students, today we're going to go over lesson 3.14, more arithmetic and complex numbers. Okay, so more arithmetic and complex numbers basically just means we're going to practice a little bit more. So today's learning target is I can do arithmetic with complex numbers. Let's go over the warm-up. So which one doesn't belong? And I'm going to give you guys a couple of seconds to think about it and come up with a sentence as to which one of these does not belong. Okay, so now that you guys had a chance to think about it, whenever we have these, which one doesn't belong, all of these don't belong or do belong, because every single one of us is a little bit different. So the first one, A, does not belong. It is the only one that involves an imaginary number that is purely imaginary. So all of these other ones are complex numbers with real numbers and imaginary numbers. Also, it's the only one that with a negative real value. So what they mean by that is if I were to convert this into, if I were to simplify this, this would become -1. And the reason for that is because we know that I is equal to the square root of -1. So if I wanted to square that, I would have to square the square root of -1. And we know that the square cancels out the square root, so that equals to a -1. And also it is the only one that does not involve having a complex number. So like, for example, a real with an imaginary. That's the reason why I squared doesn't belong. B doesn't belong because it's the only one that involves a sum of two complex numbers. So here you have a complex number plus a complex number. So this one doesn't have that. This one doesn't have that either. So that's why B doesn't belong. C doesn't belong because it is the only one with an imaginary term when written in the form of A plus BI, where A and B are real numbers. So what they mean by that is basically you have a complex number and it is written in the form of A plus BI. This one's not, this one has two of them, this one has two of them, and this one's just one. It's squared, so we know that this will eventually become 1 plus I times 1 plus I. And then the letter D does not belong because it is only one that is a product of two different complex numbers. So in this case, it is a product because we are multiplying, but you get the exact same complex number. In this one, you have two different complex numbers because one is adding and the other one is subtracting. Okay, so that is your answer for number 1. Now let's move on to the first activity. In this activity, it says write each power of I in the form of A plus B, where A and B are real numbers. If A or B is 0, you can ignore that part of the number. For example, 0 plus 3i can simply be expressed as 3i. So we have learned, actually you need to try these on your own. I will give you guys about 10 seconds for you to think about what the answers with these would be. Okay, so now that you've had a chance to think about these on your own, we have learned that 0, anything to the power of 0 is what, ladies and gentlemen? Anything to the power of 0 is always equal to 1. Now, I to the 1 power, we just know that anything to the 1 power is just that thing, so this would become I. I to the 2nd power, we just discussed that in the warm-up, but I to the 2nd power will equal to -1. I to the 3rd power, see this gets a little bit more interesting. Well, if we know that I to the 2nd is -1, then I can break this up as I to the 2nd power times I to the 1 power. And we know that I to the 2nd power is -1. So -1 times I is the same thing as -I. And finally, I to the 4th power, we'll break this up the same way. So we know that I to the 4th is equal to I squared times I squared. And we know that I squared is the same thing as saying -1. So we go -1 times -1, which equals to +1. All right. So now that we have that, let's go ahead and break this up the same way. So if I were to break this up in the form of exponents, I know that I to the 4th power is 1. So then I to the 4th power times I is equal, well, to the 1 power is equal to I to the 5th power. And we know that I to the 4th power would be 1. And 1 times I is the same thing as I. So I to the 5th is equal to I to the 6th, same process. We're going to break this up. This is the last one that I do, and then you do the other ones on your own. So I to the 6th power is going to be the same thing as saying I to the 4th times I to the 2nd power. And we know that I to the 4th power based off of this pattern here is 1. And we also know that I to the 2nd power is equal to -1. So I get 1 times -1, which equals to -1. Now, I hope you guys are seeing a pattern here. So if you were to figure out this pattern, I, -1, I, 1, then I, -1, I to the 7th would be -I, and then I to the 8th would be 1. So now that we have this pattern built here, I want you guys, or you all, sorry, to try I to the 100, and I'm going to give you about 30 seconds to figure that out. All right, so I to the 100th power is basically, we have to follow the same format that we did here. So if you haven't realized it yet, this format follows a pattern of 4. So every single time we go 4, we repeat the pattern. And the pattern is I to the 2nd power, I to the 3rd power, and I to the 4th power. And I is just equal to I squared is equal to -1. I to the 3rd power is equal to -I. And I to the 4th power is equal to +1. So if I wanted to know what I to the 100th is, I would have to break this down. Well, first of all, since we're going through a pattern of 4, what times 4 will give us 100? So we know that I to the 4th power times, or I guess to the 25th power, would give us I to the 100th. So in this case, we know that I to the 4th to the 25th power is equal to 100, I to the 100th. So we have learned that I to the 4th is the same thing as 1. So I'm going to replace that with 1. And I end up getting 1 to the 25th power, which is equal to 1. Okay. And here we do the same process. So I to the 38th, we know that we can break this up by, if we were to multiply 4 times, actually, I'm going to go ahead and let you guys figure this one out by yourself. I already gave you a starting point. Go ahead and do that now. Okay, so now that we have this, we know that 4 times 9 is equal to 36. And we have 2 left over. So if I were to multiply this times I to the 2nd power, I will end up simplifying this to I to the 38th power. Well, since we know that I to the 4th is the same thing as saying 1, so then we have 1 to the 9th power times, and we know that I to the 2nd power is equal to a -1. So then we multiply this by -1, and 1 to the 9th is just 1 times -1, and our answer equals to -1. So I to the 38th power is equal to -1. There's another way for you to do it if you know the pattern. You just simply count starting at 1 and you count all the way out, all the way to 38. So for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, all the way till you get to 30. Well, in this case, 36, then you say 37, 38. So this 38, I to the 38 will land here, which is equal to -1. Okay. So I kind of went ahead and explained it when you guys were supposed to try to do it. That was my bad, but I'm just going to continue from here. Okay. So now the second activity is just a little bit more practice on adding these terms up. So what I want you all to do is I want you to take about a couple of minutes, work these out on your own, and then I want you to write down those answers. And once you're done writing those answers, I will go over these in this slide. So right now, I want you to try the first one by yourself. Go ahead and do that now. Okay, so now that you guys are back, I'm gonna go ahead and show you the answer for the first one. The answer is 10 plus 5i. And now I'm gonna work it out for you. So whenever we have two parentheses separated by a plus sign, that means we're adding these two complex numbers. And if you guys have been doing your work, you will know that whenever you're adding two complex numbers, all you gotta do is add the real term with the real term and the imaginary term with the imaginary term. So here, we're gonna add the 7 plus the 3, and 7 plus 3 is 10. And then we add the imaginary, 9i minus 4i. 9 minus 4 is the same thing as saying 5. Okay. And that's how we got our answer. Okay. So now go ahead and take a couple of minutes or seconds to figure out for part 2. Go ahead and do that now. All right. So now that you did that, the answer for number 2 is negative 8 plus 6i. And if you can see my answer here. And now I'm going to work this out for you as well. Well, whenever you have a term outside of the parentheses, that term needs to be distributed. Now I'm going to distribute this 2i times the 3. So 2i times 3 is 6i. Now 2i times 4i will be 8i squared. And now we have learned that we can simplify 8i squared. And if we simplify I squared, we end up getting 6i plus 8 times, and we know that I squared is equal to negative 1, which will simplify this as 6i minus 8, because 8 times negative 1 is negative 8. And all we have to do now is just rearrange this so it could be in proper complex form. And that's how we get negative 8 plus 6i. Okay? So now go ahead and try the next one on your own. Go ahead and do that now. All right, you should have already been done. So when we have this situation, our answer is gonna be 25. And now I'm gonna go over this problem here. So this is a foiling problem. So 4 minus 3i times 4 plus 3i. So we're gonna FOIL this, and when I say FOIL, I literally mean we're gonna be multiplying. So 4 times 4 is 16. 4 times 3i is 12i. Negative 3i times 4 is negative 12i. And finally, negative 3i times 3i is equal to negative 9i squared. Okay, so now here we can simplify like terms. We know that a 12i minus a 12i, these terms right here, since they're the same, but they're opposite numbers from each other, those will become 0. So we have 16 minus 9. Now we learned that I squared is the same thing as saying negative 1. So that becomes negative 1. And now we multiply negative 9 times negative 1. And we end up getting 16 plus 9 times 1 is 9. And when I add 16 plus 9, I end up getting 25, which is what our answer was. Okay, so now go ahead and try the next one on your own. This one's just a simplifying an imaginary number to the 4th power. Go ahead and do that now. Okay, so now that I gave you a couple of seconds to think about it and try it on your own, if you need to press pause on this video. But here, our answer is going to be 16. So we're going to go ahead and work this out together. So here we have 2i to the 4th power, which means anything to the 4th power means we got to do all this 4 times. So 1, 2, 3, 4. And then we're going to put 2i inside of these parentheses. 2i. So we always multiply the numbers first. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And I times I is I squared, times I to the 3rd, times I to the 4th. So this becomes I to the 4th power. And we have learned that I to the fourth power is the same thing as saying 1. So then 16 times 1, and when we multiply those two together, we get 16. Okay? All right, so now the next one looks difficult, but it's really not. All right, so go ahead and try this one on your own. I'll give you a couple of seconds to think about it. All right, so now the next one, this is the subtraction problem. Our answer is going to be 8 plus 2i square root of 5. And it's a subtraction problem because we have two parentheses being separated by a minus sign. So we have 1 plus I square root of 5. And then we have negative 7 minus I square root of 5. Okay. So whenever we have a subtraction in between two parentheses, we know we have to distribute that subtraction there. So then we end up getting, I'll work this one downward and then I'll work that one over here. So here we have 1 plus I square root of 5. A negative times a negative is a plus, positive 7. A negative times a negative is a positive I square root of 5. And now it's just simple combine like terms. What's 1 plus 7? That's 8. Okay, and now this is the part that might be confusing for some, but literally there's just an invisible 1 in front of these i's. So since they both have I square root of 5, I square root of 5, we could just add those numbers. So 1 plus 1 is equal to 2. And we get 2i square root of 5. We are not multiplying the i's because this is not multiplication, this is addition, and this is our answer. And now take the next couple of seconds to see if you can try to figure out this problem. Now this one's a little bit confusing because it has fractions, but don't be afraid of the fractions. They're easy. Go ahead and do that now. All right, so welcome back. So now I'm going to work this out for you. The answer is negative 1 over 8i in case you want to figure out if you did it correctly. If you did do it correctly, give yourself a round of applause. But make sure no one's looking at you because you're going to look kind of weird. But it's okay. So now let's work this out so that you can see if you did it correctly. So we have parentheses 1 over 2i times 1 over 3i times 3 over 4. Oops, that's a very ugly 3i. All right. So whenever you're working with fractions, you always multiply across the numerators times the numerators, the denominators times the denominators. So here we get 1 times 3 is equal to 3 over 2 times 3 is 6. 6 times 4 is 24. So we get 24. And now let's deal with the i's. I times I times I would be I to the third power. Now we can reduce the 3 and the 24 by dividing numerator and denominator by 3. So we end up getting 3 divided by 3 is 1. 24 divided by 3 is 8. And we can now simplify I to the third power. Now, if you remember our pattern, I to the third power is the same thing as saying negative I. So we have 1 over 8 times negative I, which is equal to negative 1 over 8 I. That's our answer. Okay. If you guys have any questions, please make sure you email your teacher, your Algebra 2 teacher, because we are awesome and we're willing to help you as long as you have questions. All right. So now what we need you to do is the cool down. But before the cool down, you need to go back to Schoology and you need to click on this link, Second Practice Problems and Learn Zillion. So basically today's lesson is all about practicing. So you guys need to go click on that link and go practice some more of these problems. Once you're done practicing, you need to go back to Schoology and you got to take the cool down. Remember that your grade is mostly based off the cool downs. So go ahead and make sure you do those and you do those correctly because that is how we're grading you. And finally, thank you. And you guys are awesome. All right, I hope you guys understood this lesson. If you did, thank you very much. If you didn't, then I'm sorry, but please email your teachers, okay? So with that being said, let me go back to stop sharing and let me go ahead and stop this recording. Have a good day, everyone. Bye.